The central limit theorem says that if we have a population, and that population does not have to be distributed normally, for example, it might have some funky distribution with several peaks, maybe even a tail off to one side, but that population has a mean, a center, and it also has a standard deviation, or a spread. And if we were to sample sizes of some given value n, we would get an average. And if we repeated that process over and over again, we would get lots of averages. And those averages would start to distribute themselves normally. So all our various x bars would distribute themselves normally. And the average of all our averages, in other words, the center of all our averages, would be the same as the center of the original population. So those two match. Also, the standard deviation of all our sample means will be the standard deviation of the population, this up here, divided by the square root of our sample size. And if we were working instead with proportions rather than means, suppose we were getting samples of size n and we were getting proportions, those too would distribute themselves normally, just like the means would. And the average of all our proportions, all our p-hats, would be the proportion of the population, same as the p in the population, and the standard deviation of all our p-hats would be pq over n. And that's a pretty powerful idea. But what I want to talk about for a few minutes now are the caveats to this theorem, because certain conditions have to be met in order for the central limit theorem to apply. The first condition that must be met for the central limit theorem to apply is that the sampling must be done randomly. And that's easy to say, but it's very hard to do. And many sampling techniques are inherently not random. For example, telephone surveys often miss people who don't have telephones. Also, call-in surveys, for example, when you call in for your favorite artist on American Idol, are also notoriously non-random because those people who call in are self-selecting. It's very difficult to sample truly randomly, and we're going to spend a whole unit covering that. But if you're not sampling randomly, then your samples are not going to be centering themselves around the true average that you're trying to calculate. The second condition that we have to meet is that the sample size must be less than 10% of the population. And if we keep the sample size small in relation to the population, then as we select people for our sample, for those left back in the population, the chances of being selected don't change much. But once you've removed a significant chunk of the population, and this threshold is about 10%, then the chances of being selected, if you're still in the population, changes in a significant way, and we want to avoid that happening. The third and final condition that must be met is that your sample must be sufficiently large. And if you're calculating means or averages from your sample, you want your sample size to be greater than 30. And that's somewhat of a soft threshold, but again, it does have some statistical justification. And then if you're instead calculating a proportion, say the proportion of people who will vote for a certain candidate, you want to make sure your sample is large enough so that you're expecting at least 10 successes and also at least 10 failures. So you're expecting at least 10 people to vote for the candidate and at least 10 people to vote against the candidate in your sample. And if these three conditions are met, you can feel confident that the central limit theorem applies.